Hello, my name is Aurmanni, and I'm here to present my design project for ARC 199.2. This is the presentation flow we have today. I'll start with a small preface, followed by the introduction, and then finally moving to the design proper. So starting with the preface, just a few things, a few facts to help frame my project. First, it is said that in a mere 25 years, the whole of Manila will be subject to flooding. This, along with the problem of overpopulation, contributes to the land and housing shortage we have in the Philippines right now. One can only imagine how much worse this will get in the future. Secondly, ever since the Industrial Revolution, 7.8 billion tons of plastic waste has been left on the planet till this day. And the majority of this plastic waste is actually found in the ocean, in what we call ocean garbage patches. Furthermore, ever since the 21st century, countless of projects have tried to clean up these garbage patches, but they've all since failed due to the collection site being too far away from the processing unit or the actual landfill dump. Next, also in about 30 years, just in 2050, it's estimated that global oil reserves will be completely depleted. This leaves countless of oil rigs left out in the ocean, obsolete, and in need of environmentally safe oil rig decommissioning. Now, I believe that it's time for us as a civilization to address these problems, and I believe that architecture shouldn't take a backseat in the changes to come. And I believe that design has a very proactive response. It can be a proactive response to these problems. And with that, I'd like to present my design project, the Paglipat Clean Oil Rig Powered Ocean City in Service Contract 38, El Nido, Philippines. So let's start with the design statement. What is Paglipat? So Paglipat basically is a uh, development out in the ocean that collects ocean plastics in its direct vicinity, then converts it to clean energy, powering an attached holistic human settlement. Paglipat is also retrofitted from pre existing oil rigs, offering a sustainable means of oil rig decommissioning. So, therefore, Paglipat refers to the following: the moving of human settlements into the ocean, the shifting of design ideas towards sustainable practices, and turning the oil rig, an international symbol of pollution, into a beacon of hope and sustainability. So the site, as said, is in Service Contract 38 of El Nido, Philippines. Specifically, it is the Malampaya Ace oil rig, which is an existing platform here in the country. Um, in the vicinity and location, we see that Service Contract 38 is actually one of many petroleum service contracts here in the Philippines. Specifically, it is around 60 kilometers away from the shore of El Nido. And on the map on the right, you see the location of the platform in respects to the service contract and in respects to El Nido, Palawan as well. In the site analysis, I was pleased to find that the site is generally safe from earthquakes, and this was largely due to the ocean setting. And because of this also, the site is also free of flooding and landslides. However, um, because of the ocean setting as well, there's also negative effects like tropical cyclone threat. You can see that the site is in the TC Genesis area. There's also a threat for distant tsunamis. And out in the ocean, there's always a threat of heat and glare, which is shown in the sun path diagram. Now, moving on to how I tackled the project. The approach I took was an integrative approach for sustainable architecture supported by the concepts of aquatecture, biophilic slash regenerative architecture, and modular design. So how I did this was actually taking sustainable cycles and integrating them into the very design and the very core of my project. And I done this by first getting the sustainable cycles in aquatecture that support human life. So these are the following. First is food and fresh water obtainment. Then there's energy production, and there's also habitation. And how it's integrated in the design is actually two ways. So first, it's integrated in the very space programming, and it's also integrated in the equipment demand and size. So for these cycles, there's very specific equipment that is needed, and these figures are taken in account in the design. So with that, let's move on to the design proper, starting with the entirety of the development you see on screen right now, which is the paglipat phase 1, the clean oil rig. And also we'll go into the concept development on how I got to this configuration. So first, it actually started with taking the pre-existing structure and taking it down to its bare bones, or its structural elements only. And then from there, I identified the major modules, which I was able to assign functions to each based on the architectural programming, and also based on the equipment and demand size as previously stated. So an example would be the module in the center, highlighted in orange, eventually became the materials and energy production core. And this was because the floor to floor of that module was quite high, which is very apt for the larger equipment. So moving on, I wanted to expand on this further, and this was done with the addition of more modules to the pre-existing structure. So how I did this was actually I established a hexagonal grid where I could add the modules onto, and this hexagon was actually taken from concepts in architecture and modular design. So however, going back to the previous configuration, I found that it lacked connectivity, and there was a problem of movement through the major modules being very linear. So I fixed this by refining the hexagonal grid, and I did this by moving the pre-existing structure to the border of the grid, and this allowed me to actually add a large central module to connect the site. So this connection is seen most in access and transportation. So I wanted to establish the user paths, and this was first done by establishing that the main transit between modules would be watercraft. So this was reflected in how I put docks in each module located at sea level, which in this case would be the ground floor of my development. Then afterwards, I put bridging on top on the first floor between traffic routes that have high traffic. So it's in the first floor so that it would not impede on the watercrafts below. And this configuration actually made a special space configuration where I could direct my users to the first floor instead of the ground floor, allowing me to put service spaces in the ground floor, my main entrances and my public spaces in the first floor, and the module proper in the succeeding floors. And this really came down to private, public, and semi-public. And this type of space configuration is very advantageous in terms of maintaining access hierarchy, intuitive wayfinding, and it's best for security, which we'll see later. So next, I went back to form finding because I saw the development still lacked cohesion for me, and this was mainly due to my reliance to the pre-existing structure. So how I fixed this was by implementing an architectural skin, which was the best use case, which we'll see in the actual details later. So going back to form finding, first I enveloped the buildings, then I softened and curved the edges, and then I moved the form around to account for entrances and openings, which also included covering the bridges when possible. And with that, we're left with a final skin. So here is the perspective and the line art of my skin. And for the actual details, it has an organic form, the curving forms, because it follows the biophilic architecture approach where it resembles a aquatic life form. And then the form is also reminiscent of strategies in hurricane and storm protection. Next, the mounting system. The panes are actually mounted via ball joint on a frame, which allows for opening and adjustment, which provides sun shading and natural ventilation. And then lastly, for the panes itself, it's made out of ETFE, which is an engineered plastic that can be made from recycled materials, which is favored in architectural projects because of its lower thermal conductivity. It has a high melting point and high corrosion resistant, which I found was very important in the ocean setting. This is the development as a whole right now, and let's go through the parts. First, we have the food and water production core, which produces such with the use of hydroponics, aeroponics, and desalination. Next, we have the energy and materials production core, which is a multi-technology energy generation building. It also collects and converts ocean plastics into the aforementioned energy and even materials. Next, we have residential apartments, which houses our users, the scientists, the researchers, the workers, their families, and early adopters. Next, we have the central island, which is the large module, which features recreational spaces and commercial spaces as well. Lastly, we have small modules, which are the supporting facilities, which houses anything that the development needs, which are security posts, vehicle hangars, livestock farms to support the food production core, and etc. So with that, we have the final development, and let's go to each component now. So first, we have the central island, and with discussing this, we'll also discuss some design strategies that we did for the entirety of the modules. So here's sample elevation. And here is the section which features the displacement hull, or basically the floating foundation, which we'll go into later in my maps. So basically for the central island, I wanted it to be something like a downtown where the engineers can go to when they have break, or the families can go to on the weekends to unwind. So that's why it features commercial spaces and recreational spaces, which we'll see later in the plans. The ground floor plan is here. We can see the emphasis on the docks, which can accommodate anything from small boats, passenger ferries, whatever, to very large multi-cargo ships, which we see here. In the docks also is where I put the recreational parks. And in the building proper itself is focused on service, which we'll see in a blow-up later. Moving on to the first floor plan, we can first have a glimpse on the very standard 6mm two-way road network, but in my development, it's mainly for light electronic vehicles and bikes, which we'll see later again in the maps. Also seen here is the access to the recreational parts on the ground floor. So to take advantage of the very scenic views of the ocean, the access is a pedestrian view ramp. And for other access, we also have view elevators for the PWD and for the people who just don't want to take the ramp. Also seen here are the building propers itself, which houses the commercial spaces and also the community center for the entire development, and the clinic, which serves as the first aid. So going back to the ground floor, here's a blow up. As you can see, the inside building is actually focused on service. So there in gray, we have our standard service, waste storage, water, HVAC, power. And then there in orange, we have the service for actually the whole development, which comes in the form of something I call variable storage, which stores utilities for the whole development. So stuff like water, energy, or even supplies, they're stored here in the central island because, as we said before, the placement is very strategic. Also in the service, we see the first glimpse of the multi-purpose hangar, which is for docking ships, for maintenance, for everything. But the main use, I would say, is for life support systems. So here we'll find our lifeboats. And as you can see here and in the rest of the modules, our fire exits all lead up to this multi-purpose hangar. So moving on, here's a utility line diagram. So for things like water pipes and energy lines, it runs through the ocean and into the ocean bed. This is actually very common and already done in pre-existing oil rigs and the like. So here are some views of the central island. First, we have the approach view. We have a view of the recreational parks. We have a view of the multi-purpose hangar seen here in this module. Here's also a sample for the commercial spaces. And with that, let's move on to the next module, food and water production. Let's start with some elevations. We have front, right, rear, and left elevation. And then now let's look at space programming, because the goal of the design was to integrate the sustainable systems into this space programming. So for the food and water production, these sustainable cycles are the food cycle, water cycle, and my user cycle. So for food, starting from the top, we have the germination labs, the seed germination, and the laboratories. And then moving that to the actual hydroponic and aeroponic setups where the plants are grown. And then below that, in the first floor, we have the kitchen and the produce handling where the crops are uh, processed. And then at the very bottom, we have the general store where the products can be sold throughout the development. And it's on the ground floor, so it's accessible also for everyone. For the water cycle, we'll start at the ground where we get ocean water service in and out. And then in the middle, it's converted into freshwater in desalination arrays, and then it's also stored in overhead tanks. And then for our user cycles, at the ground floor, as said, we have our lifeboats, and we also have a boat entrance. In the first floor, we have the main entrance, so we also have things like the recreation and cafeteria. And then above that, we have the module proper. Above that, we'll have the offices, and we'll also have the admin and the helipad. So this is seen in our section, the latitudinal section. This is the longitudinal section, and let's move on to our plans. So first, in the ground floor plan, the focus is the general store, which is sort of a grocery, so people can dock here and buy their whatever they want, their needs, their produce, their meats, and they can even buy from food stalls. Also here we see the service, so the multi-purpose hangar, the HVAC, the ELEC, and then we can also start to see some of the food and water production things in the produce storage. So this is carried on in the first floor. In the service area, we see also the produce handling and the kitchen, which is connected to the cafeteria. The cafeteria, which connects to the overall purpose of the floor, which is the main entrance. So we have the lobby, we also have the access from the other modules, we also have shared break rooms, etc. Moving on, let's go to the module proper first. The second floor is focused on the water production. The actual equipment we'll touch upon in our MEPs. Moving to the third and fourth floor is food production, so we have our aeroponic and hydroponic setups. Then moving to the fifth floor plan, we change and we go back to a user-centered, where we have our offices, the beginning of our offices. Here we took advantage of the deck in the pre-existing structure and the connection to the other module and made it into a park. Here as well, we have a tree reserve and nursery, which is mainly for the tree saplings to be used in the development. And also in the office area, we have the laboratories and seed germination. Moving on, the office is continued in the sixth floor, and also in the seventh floor where we have the admin offices, and as well as service and access for helipad. Some views. This is the approach view. This is the hydroponic setup. This is the public spaces and parks, and this is the general store. So moving on to our energy and materials production, let's start with the elevations. Front, right, rear, and left. So for the space programming of this module, the things we needed to take account were the energy cycle, the material cycle, and our user cycle as well. So first, for energy and materials, it starts off at the ground floor with waste collection, and then it's continued by waste sorting. Then it will be processed into either energy and materials. And then at the very top, we have storage for the material products and the energy storage. And then for our users, we have our boat entrances at the ground and lifeboats again. Then we have the main entrance and offices with the cafeteria and maintenance. And then finally at the top, we also have our admin and our laboratories. So here's a sample section, and then it's also shown in our ground floor plan. In the ground floor, it's devoted to the waste sorting, so the equipment is here, and then all of the equipment will go into in our MEPs. Here we'll also see the storage for the sorted waste. So here, waste is taken from either the development or from the ocean, where it is then sorted. And then it's moved to the first floor, where we have the energy production, first floor and succeeding. So in the first floor also, there is our main entrance and our offices. This is continued in the mezzanine of the first floor. But the first floor is devoted to energy production, specifically the plastic gasifier, which we'll see later. Second floor is still energy production. This time, our larger machines, like our pyrolysis plant and our biodigesters. And then in these energy floors, we also have product storage, of course. In the third floor, we have material processing, where we'll have the machines such as extruders and the plastic injectors. Here we also have storage of the product storage, and we also feature a maker space where people can take the products and create things with it, experiment. The mezzanine of this floor features the laboratories and the admin office, as well as storage for the energy. And then lastly, the roof deck, we have the solar arrays and the helipads. So here are some views. This is the approach view, the energy production setup view. This is a view of the main entrance, and this is a view of the maker spaces and the laboratories. So let's move on to our residential apartments. So front elevation, right elevation, rear elevation, and left elevation. So for the space systems here, we wanted to focus on housing, amenities, and education. So for housing, we first start at service at the bottom, and then in the first floor we have lobby and main entrance, and then above that will be the residential unit prior. For amenities and education, there's a learning center and a jogging lane at the ground floor, and then standard amenities at the first floor with the main entrance. For education specifically, there's on-site tutoring in the learning center, and then succeeding on the top floors in the residential units, we also have online learning and flexible learning. So latitudinal section, longitudinal section, and here's the ground floor, which has the learning center. So here we see the study pods, which I chose to have mainly due to the fact that we can accommodate all the different levels of education from preschool to higher years. We also see the office for the on-site tutors. We also see here the service and the multi-purpose hangar. And on the first floor, we have the main entrance and the amenities. So our amenities include the gym, the pool area, and a multi-purpose room, also a cafeteria. Here we also have the home association office and the lobby. So moving on to the third floor, we have the residential apartments. So our apartments are cut up as we see on screen. They're designed in a way that will have majority of medium suites, but we'll also have large suites and studio suites to accommodate all types of users. This is the detail. Let's go on to a blow up. So this blow up shows the medium suite or the fish suite. So this is a 3 to 2 bedroom suite. Next, we have our large suite, the Emperor Bream, which is a 3-bedroom unit with a maid's room. You can also see here that all units have access to a balcony, which is something we wanted to focus on. Lastly, in this blow up, the focus is the studio suite, the Damselfish, which, as you can see here, can be 2 to 1 bedrooms, still providing ample space. So some views. This is the residential approach view. This is a sample living room, a sample bedroom, and this is also the learning center and study pods. Let's move on to the maps. So first is the HVAC detail for the residential units. So we use a VRV system with the outdoor unit in the balcony. It's hidden and it also has storage for gardening. And this is connected to your wall-mounted FCU and your overhead cassette. For your typical HVAC, for larger spaces such as lobbies, we use a chilled water system. So this electric chiller is in the respective HVAC rooms, which is connected to jet nozzle diffusers and the aforementioned FCU, wall type, and cassette. We have our typical elevator detail. This is in the materials and energy prod, which has an open staircase. So here is the typical passenger lift and typical service lift. Let's move on to specialty vehicles. First, we have light electric vehicles. Then we have passenger boats, anything from lifeboats to ferries. Then we have our single van cargo ship and our multi-van cargo ship for movement of goods, which is designed to be accommodated in the multi-purpose hangar and in the docks respectively. Furthermore, we have ocean garbage collectors, which is based on previous projects, similar projects. Then we also have security drone, um, which is for surveillance, reconnaissance, everything. This is equipped with a camera and can also be armed, and which are deployed from the separate security module and operated from there. So security is a very big part of the project. So we also implemented an emergency shuttle detail for any threats, whereas our users can be protected until help can arrive from our security modules. So here's the detail of that. Next, we have our energy production details. So energy is made in the energy and materials production core, and then energy is partly stored here, but mostly it's sent into the central island for storage, and then from there it's distributed throughout the development. So let's go to storage machines. We have energy generators, energy transformers, and we also have battery arrays. And for actual production of energy, we have plastic gasifiers for normal plastics, pyrolysis plants for harder plastics and rubbers, biogas digesters for bio waste, and solar arrays for solar. And then we also have material processing machines such as the waste sorters, the extruders, and the injectors, and all alike. For plumbing, first water is taken from the ocean, and then it's converted into fresh water in our desalination floor. And then it's pumped into the aeroponics and hydroponics setups as seen here in the line diagram. And this is also representative of the whole development. So for the hydroponics, we have an A-frame module. For aeroponics, we have the aeroponics tower. And then for reverse osmosis, we have filtration tanks, reverse osmosis arrays, and everything until water product storage. For plumbing as well, we also have our typical fire protection layout. We see the sprinklers layout here. And then our vertical access fire exit all connect to the multi-purpose hangar. So each hangar is designed to at least have one primary high-capacity lifeboat. Then it's also supported by wall-mounted rowboats as a backup. Then for accessories, we have push-type fire alarms, smoke detectors, and fire detectors, and pendant-type sprinklers. So for structurals, first we have the floating foundation, which is explained as follows. So first we have the building proper, which has the gravitational force. Then on the sea, we have a stabilizing slab, which increases the surface area, stabilizing the structure. And then below sea, we have the displacement hull, which creates a buoyant force supporting the whole structure. And we have anchorage to the seabed. So in this section and plan, we actually see the displacement chambers, which displace water, creating a force that pushes the structure and keeps it afloat. You can see in the section that it's naturally stable, which means that the center of buoyancy and the center of mass is at the same height, creating a very stable foundation. And then next we have a detail of the shear wall, which is basically a shear wall which is waterproofed on each side with fiberglass panels, two plies that are cross-sandwiched, and then in the side facing the water, we have eco-concrete bricks which promote biofouling, which helps mitigate the effect on the ecosystem. Next, we have our semi-submersible structure, which is the pre-existing foundation, which is mostly steel construction. So we use I-beams, wide flanges, and steel deck. Here is a foundation plan and a framing plan. Next, we have miscellaneous structural details. So for the bridges, since it combats waves and tides, it also uses a displacement hull. It uses flexible concrete, and it also has bridge dampening systems. This is a latitudinal section. And for the plant box, we use tropical species, short root, and tall shrubs, which are calachuchis and things like trumpet trees. So for last, phase 2, this is the expanded city. So we can add modules, anything from industrial, residential, commercials, anything that the development would need. It can also add wind farms, solar farms, and park and recreation, things like churches, beaches, and floating parks. And here's a sample master plan. As you can see, the configuration in phase 1 is repeated modularly so that it can allow for configurations in layout and modular expansion. So here are just sample views. This is the large module. a sample institutional island. This is a view of a man-made beach. This is a sample small module, a floating park, and this is a view of a basketball court. So with that, I'd like to end my presentation here. So I'd like to thank you for listening. And if you wish to contact me again, I'm Arman Angeles, and you can contact me on the email below.